Hey, you're back. Great. Recharge, got something to drink, got something to eat. Now you're ready to hit the second half of this practice review. Remember, no rules. If you want to just listen, hey, just listen. If you want to just quiz yourself and listen to the definition, the concept, and then see if you can figure out on your own what word we're talking about, what term we're talking about, awesome. Anyway, hey, let's get started. All right, think about the last time you were running. And if you run a lot, and especially if you run on different types of surfaces, you might find this one an easy one to grasp. It is easy to run on concrete, but much more difficult to run on sand. It's extremely more difficult to run in shallow water and almost impossible to run in deep water. Now, the reason I say all that is that electric currents sometimes find it difficult to travel through some materials, but find it easier to travel through other materials. And we talked about materials like conductors and insulators. But this vocabulary word, the formal definition, is a measure of how difficult it is for a charge to flow through a material. If you said resistance, you are correct. Again, and let's go back to the analogy of running. When you're running on concrete, the only thing really resisting you is the air friction. Not much. You really can't feel it. You're not moving that fast. But if you run on sand, well, the soft sand provides more resistance. If you run through shallow water, that water provides more resistance, and deep water even more resistant. Well, same for electrical current. Electrical current can travel through some things with very little resistance, other things with a lot of resistance. Good job on this one. Okay, we're talking about circuits. There are two types of circuits. In one type of the circuit, there is only one path for the current to take. For example, you have a battery, a voltage source. Wire comes out of the battery, goes to a light bulb, and goes in through one side of the light bulb. Another wire comes out the other side of the light bulb and goes right back to the battery, forming one loop. Okay? In this type of setup, the electricity can only travel in one direction. If you said series circuit, you are correct. Remember, if there's just any break in a series circuit, the electrical current stops. Everything comes to a halt. In this type of circuit, you have different parts of the circuit are on separate branches. The cool thing about this circuit is that if one of those branches breaks, there's a break in the circuit somewhere, well, the electrical current can take another path. And the whole circuit doesn't shut down just because one branch is broken. Think of, instead of having a NASCAR track, having another NASCAR track outside that one where you have two tracks. If one track gets broken, something happens, a wreck, something bad happens, then, well, the cars can just get on the other track and complete the circuit. Good luck. If you said parallel circuit, you are correct. Hey, try to think back to math class. Your math teacher taught you that when two lines are parallel, they run alongside each other and they never intersect. Well, when we're talking about electricity, again, parallel means that there's more than one path for the electrical current to take. The good thing about this, if something breaks down, you have a break in the circuit, the electricity can still run. Good job. All right, this definition is a connection that allows a current, electrical current, to take the path of least resistance. For example, you come across an extension cord that's plugged into something, and the extension cord is frayed. It has an opening, a cut in it, and that wire is exposed. Well, you reach and you grab that. I don't suggest you ever do that, but if you did, you would get shocked. Because believe it or not, your body, because you're mostly water, your body provides a path of least resistance. The electricity would rather flow through you than that wire. So again, the formal definition, a connection that allows a current to take the path of least resistance. If you said short circuit, you are correct. Remember, this is that connection that allows a current to take the path of least resistance. You grab a wire, you grab an exposed wire, you are providing that electricity an easier way to travel through you and get to the ground. Therefore, we say you're a short circuit. No pun intended. Most buildings have a wire that connects all the electric circuits to the ground or to the earth, where it can be kind of safely dissipated, get away without hurting anybody. Okay, the definition is when charges are able to flow directly from the circuit into the earth in the event of a short circuit. If you said grounded, good job. Hey, ground is a good thing. It's what protects us in case there's a short circuit. It allows that electricity to take an easier route, because again, electricity is always going to take the easy way. And if that easy way is through a ground, then that means it's bypassing you and going straight to the ground, into the earth. Good job. Okay, if you looked at extension cords that are relatively old, you might find them only having 2 prongs. Pretty much any extension cord that you buy today, especially if it's an orange one, is going to have an additional prong, a total of 3. And this odd prong is going to be round, and it connects any metal piece of the appliance, whatever you're trying to run, to the ground wire of the building. Again, this is designed to allow electricity generated from a short circuit to travel back to the earth without hurting you or the appliance or whatever you're using to run the electricity. Pretty easy definition, I think. The answer is 3rd prong. Good job. Electricity is a funky beast sometimes, in that it can surge or it can get real powerful for a short, brief time. Now, if you have something that runs off electricity, well, if it all of a sudden builds up and you have this strong surge of electricity, it might be too much for whatever you're trying to run, especially if it's a radio or computer especially. Well, we put these special little devices inside very sensitive types of electronics, and what these devices do is whenever you have this big surge of electricity that comes through there all of a sudden, this device will break. It has a little thin strip of metal that will either melt or it'll break, and it will prevent that electricity from reaching the sensitive object. Again, this is designed to protect whatever you have that's running off the electricity. If you've ever had to replace one of these, you know that it's called a fuse. If you've never had to replace one, well, when you get a car, you're going to have to replace one, I guarantee you. Again, this object is designed to break. It's designed to purposely break to prevent a large surge of electricity from hitting something that is a whole lot more expensive than a fuse to replace. Good job on that one. We are almost finished. Again, I want to thank you for sticking in there. This video is already at 25 minutes. So again, if you can't do this whole thing in one shot, you got to take a break. That is okay. We are almost finished though. Thank you for sticking in there. This definition, this next one, every house has one. It's a reusable safety switch that breaks the circuit when the current gets too high. Okay? In my house, in my garage, I have a small little case on the wall, and I open it up and it has several of these. And sometimes when, especially during severe weather, the house will get hit with too much electricity, and one of these will go off, and I'll have to go out there and reset it. Again, the whole purpose of this is to protect the house and the appliances in the house from a huge surge of electricity. If you said circuit breaker, you are correct. Again, chances are every house, every apartment in the city has several of them. Good job. In the 1800s, this scientist, his first name was George, he performed experiments that demonstrated how current, voltage, and resistance are related when it comes to electrical currents and electrical resistance. Okay, the formal definition is a law that says that the resistance is equal to the voltage divided by the current. I think by mentioning law, I kind of gave this one away. This is Ohm's law. George Ohm's law says that the resistance is equal to the voltage divided by the current. Good job. Okay, we are done. Wow, 26 minutes. Didn't really mean for it to be that long. Again, if you weren't able to do this all in one shot, that is okay. However, if you need to go back and do it, that's fine. You do this, you watch this video, and you listen to it as many times as you need to before you feel comfortable coming into class and taking the test. Again, Like I said at the beginning, thank you so much for making the effort to do this. I think it's going to make a difference on your test score. Please feel free to leave any comments. Anything that you might add would be great. I can use your comments to improve and do better next time. This is Coach Seckinger. I'm out of here.